Hi, in this video I want to focus on the Raspberry Pi and more specific the running of the binary counter. And the last few times it turns out that the middle LED LED, which is here, refuses to either burn or to stop burning. And the question is why that happens, but interesting is also that when I start the counter algorithm on Raspberry Pi 1, it first waits for the input for the control, which is on the Raspberry Pi 2 here, and when it runs, the counter starts working nicely, just doing what it should do. However, when I stop the algorithm on the Raspberry Pi 2 and I start it again, the counter algorithm doesn't respond properly or at all. Now if you can see here in the code, everything it does here is nothing, because time and GPIO output are commented out. So it only prints reverse and it prints done. So all it does is actually going forward. However, after restarting it, it doesn't do anything, like I said. So I end the algorithm here, I end the algorithm here, and it says else if LED 1 is 0, LED 2 is 1 and LED 1 is 1, which is the binary representation of 6, but it should go on. So I start it again, and it says this channel is already in use, but I completely ignore it. It just waits for input, which I give it here. And let me reduce the lighting. It doesn't do anything, so I would like to go back to a former algorithm, 14, which should work. How? Let me try a few things. Yes. You see here, let me try to make it more clear here. You can very clearly see that the algorithm works. 5, 6, 7, back to 0, and 1, 2, 3, 4, 5, 6, and 7. So this shows that the algorithm without control just works. All LEDs work as they should. So I end the algorithm here, I go back to 15. Now it's waiting for the output for the control from this side. And while just before making this video it worked, it refuses to work. So the big question once again is why? And let's end this one. I end this and I go back to 14, see if that works properly. And it works without a hitch. So the mysterious thing is, what is the difference between the control, which at one time works and another time does not work, and the C++ code, which refuses to work this light, the second LED. And in the past I have already checked, double checked, triple checked the code, nothing wrong with that. I didn't check the wiring, which was a nuisance apparently maybe last time. So there's still some mysterious things to solve. And I wonder if I ever will, because this is a very odd phenomena. And yet, again, it doesn't work with the control from the RPi2. So, something to investigate. Oops, I need to be here. And going back to basics, 12, pin 12 is the replacement for the switch on the Raspberry Pi 1. Then it sleeps for 15 seconds, although that is not really of influence on the counter, but still it doesn't work. When I compared to the C++ code, which is, as you may remember, in GPIO test, I'll start the same code here, the control code here, and this is all all what happens. 2 LEDs, and as you can see, LED 1 is on, LED 2 is off, and LED 3 is, can I show it like this? You see it right here, is on, and that is all what happens. It doesn't count, it's just static. Going here, it doesn't show a difference in input state, which is really odd. So let's add this and it, and now it says the input state is 0, and you can see here things happening. And yes, the counter kind of works, but without LED2. Well, I did fix previously the code so that it did work. So, very strange once again. And I'll end this one and start. So VI GPIO. That is the code. Let's go all the way to a second LED, because here it's set to off, here it's set to on, etc. Whenever it is meant to be off, it is off, and whenever it is meant to be on, it is actually on. Zero, one, one. Setting values to 0, unexporting. So it is once again a complete mystery why this second LED is not running in C++ while it is in Python. The hardware is proven okay, once again, but it might look like there is something wrong here, but I doubt that that is the point. Because here LED2 doesn't work at all, and as you can see here, it is clearly set to out, and RPi2 is for LED2. It is being exported, it is being instantiated, it's being set to output, set to 0, set to 1, so anyway it should just work. And if someone has a solution, I would love to hear it on my email address, which you can find on my website. So for now, thank you for watching to this mysterious working of my binary counter, controlled supposedly, desiredly, by the RPi2, which sometimes works and sometimes doesn't. And certainly to be continued.